In class, we talked about how to calculate the average atomic mass, and so we're going to work through a couple problems using those same steps from class. All right, we're looking at vanadium 50 and vanadium 51. The first thing we want to do is make sure that we have a mass for both of these isotopes as well as a percent abundance. So when you're given a percent abundance, the first thing you want to do is you want to move the decimal 2 places to the left, and that is the number that you're going to use to multiply by the mass to get a number. So I'm going to move both my decimal places, 1, 2 to the left. If you're not comfortable moving the decimal, divide by 100. That's how you got your percent to begin with. So the first step in this problem is to take my first mass for vanadium 50, which is 49.95, and I'm going to multiply that by my abundance, now that I've moved the decimal place over, which is 0.0025. When I multiply these, I get 0.125. Okay. Next, I am going to do the same thing for vanadium 51. So 50.94 times my abundance, which is 0.9975, and that's going to give me 50.81. The last thing I need to do is to add those two numbers together. And what you've calculated so far is you've taken into account the percent abundance of this particular element and multiplied it by its mass. So wherever my percent abundance is highest, I expect the number I get from this addition to be closer to that. So vanadium 51 is 99% of all the vanadium that you find. So I'm going to expect the number I get from adding these two numbers together to be very close to 50.94. And the answer I get is, in fact, 50.9. So my number has come out closest to vanadium 51, which is expected because that has the higher percent abundance, and this takes into account that percent abundance when figuring out what the average isotope is. All right, now we're going to look at copper 63 and copper 65. My percent abundance for copper 63 is 69.17%, so I'm going to move my decimal place 2 to the left. I'm going to do the same thing for copper 65. So the first step after, well, the second step after I've moved my decimal is to multiply 62.93 times that decimal, which is 0.6917. When you multiply those together, you get 43.53. And next I'm going to take copper 65's mass, 64.93, and multiply it by my decimal, which is 0.3083. When I multiply those together, I get 20.02. Last step is to add those together. You will get 63.55 when you add those together. Looking at the periodic table, that's exactly what is on the periodic table, so I've done something right. But I can also double check that if I don't have a periodic table by looking back at my percents. Because copper 63 has a higher percent, almost 70% of all the copper you find is copper 63, I expect my number to be a lot closer to, and this is almost 63, than to almost 65. So my number 63.55 reflects this higher abundance. It is closer to that mass of copper 63.